Now let's solve one of the DI sets which has 4 questions. Now if you look in this DI set, there are 6 families, and what I've done is I've drawn a table where the families are 6. So we have to fill this table where the members would be figured out from the given data and also the number of vehicles. Now if you look the first data gives you the number of members in each of the family. Now that is given in terms of the entire data has been divided into some degrees. So what we can do is, let's say if I calculate for Sharma as a fraction of the total members you have of all the 6 families together, the fraction would be for the Sharma family would be 54 by 360, which would become, actually if I simplify, that is 3 by 20. So Sharma family would be 3 by 20 of the total members which you have. Similarly, if I look for the Khan family, that would be 90 divided by 360, which is 1/4. So similarly, if I calculate the fraction for each of these families, so the fractions which are going to be involved in this would be, one would be 3 by 20 for Sharma, 1 by 4 would be for Khan. Jan, if I calculate, that would be 63 by 360, which is 7 by 40. For the Khuranas, it would be 72 by 360, which would be 1/5. For the Batras, if I calculate, it would be 1/10, that is 36 by 360. And for the Varma, it would be 45 by 360, which is 1/8. Now to simplify, what we can do is, we can assume the total members to be a multiple of 40. So let's say my total members are 40n. This would actually make our data easy, as now if I calculate the respective members for each of the family, I'll get 6n. That is nothing but 3 by 20 of 40n, which is 6n for the Sharma family. Similarly, for the Jan family, I'll have 7n. Then Varma, I'll have 5n. Batra, I'll have 4n. Khurana, I'll have 8n. And Khan, I'll have 10n. Now once you fill this data, and if you try to see the vehicles with each of the family, so let's move on to the next data, where the table gives you the number of vehicles per person. So let's say if I want to calculate the number of vehicles per person is given to you. So let's calculate the vehicles per family. Now for Sharma, let's say if I take an example which is 0.67, which is 2/3. So if I take 2/3 and if I multiply with 6n, I'll get 4n. So 4n, if I look over here, is the number of vehicles with the Sharma family. Similarly, if I follow the other data, we can calculate for each of the families the number of vehicles. So let's go back to the previous data and I'll fill the number of vehicles per family. So first I'll fill is 4n, that's for Sharma. Similarly, for Jan, you'll calculate, it will be 7n. Then for Varma, you will have 3n. For Batra, you will have 6n. For Khurana, you will have 3n. And for Khan, you will have 4n. Now let's try to figure out the value of n with the given data. Now what is given is that no family has more than 20 members. So if I observe the data for the Khan family, that is total members are 10n. Now this cannot cross 20, so it could be less than equal to 20. Now when I do this, my n comes out to be less than equal to 2. So my possible values for n is either 1 or 2, but let's say when you put n as 2, the Jan family, total number of vehicles, if I calculate, would become 14. And you know, in the data given is that the number of four-wheelers with the Jan family is 4 in number, which means, so four-wheeler is 4, which means two-wheeler would be 10 in number. And it is given in the data that no family have more than 9 two-wheelers, which means that the assumption that n is equal to 2 is wrong. So the only choice left out is n is equal to 1. So if we figure out the value of n as 1, we can actually fill in the members as well as the number of vehicles. Now if I try to fill the table with the help of n is equal to 1, the table would something look like this. The number of members with the Sharma family would be 6, with the Jan family would be 7, with the Verma family would be 5, with the Batra family would be 4, with the Khurana family would be 8, with the Khan family it would be 10. Similarly, my number of vehicles will come out to be 4, 7, 3, 6, 3, 4. And with the additional data in the set, I can write for the Jan family, number of two-wheelers are 3 and number of four-wheelers are 4. Similarly, for the Batra family, I can write this figure as 4 and 2. Now let's see, if I look over here, I can answer the questions which are based on this. And the data which I am having for the Sharma and the Khan family, if I see, the number of vehicles are same. That's 4 each. So what I can do is, for the Sharma and the Khan family, let's say if I write for the Sharma and the Khan family. Now when I talk about the number of two-wheelers for the Sharma and Khan and the number of four-wheelers. See, the possible combination could be, because of total vehicles is 4, the choice is for both the families Sharma and Khan, it's either 1, 3, that's possible, or maybe if I see 2, 2, or maybe 3 and 1, or maybe 4 and 0. So that's a possibility I have for the Sharma and the Khan family. Similarly, when I do the breakup for the Verma and Khurana family, because both the families have 3 vehicles each, so my breakup could be something like this: 1, 2, or 2, 1, or 3, 0. So these are the breakups which are possible, right? Now let's try to answer the problems which are based on this data set. Let's come to the first question of this data. The question is, number of four-wheelers with how many families is definitely more than that of two-wheelers. Now let's come back to the table. If you look this table, what we can be sure of is that the Jan family is definitely having more number of four-wheelers as compared to number of two-wheelers. And for the rest of the families, it would be not possible to figure out. So what I can say is, if I look this question, so my answer should be option A. Now let's move on to the second question of this. Now what they are asking you is, by what percent can the number of two-wheelers with Verma family be more? So they are asking you, let's put Verma family, they are asking you two-wheelers, and if I look for the Khan family, right? So the problem is, by what percent the number of two-wheelers with the Verma family be more than that with the Khan family. So let's go back to the table again. Now what I can take is one of the possibility with the Verma family is 3, 0, which means let's say 3 are my two-wheelers and 0 is the four-wheeler. And what I can do with the Khan family, I can go with 1, 3, which means 1 is two-wheeler and 3 is your four-wheelers. So let's see if I can answer now the data. So what is the percentage change if I look? So I have taken 3, 0, correct? And I have taken 1, 3. So the possibility if I look over here, let's say how much more, it is 3 minus 1 on a base of 1, and if I multiply with 100, I'll get 200%, which is your option number C. Now if I come to the next question, for which family is the value of the product of the number of members and the number of vehicles the minimum? Now this is very obvious with the data. If you look over here for the Verma family, the multiplication of the number of members, that is 5, into number of vehicles, that is 3, 15 would be the lowest. So my answer, if I look, should be option B. Now let's move to the last question. Which family does not have any four-wheeler? So if I go back to the table, I cannot fill this table completely. So I really, if you look over here, the data cannot be figured out from the given table. So the answer should be option D, which is cannot be determined.